Hello, my name is William Billows, and for this final lab, I will be modeling a collision. So the objective in this lab is to model a collision and to find the energy lost. So here are the preview of results. So we were able to model the collision, but we were not able to calculate energy lost on the GlowScript code because the velocity was averaged from the data and not exact. So that unfortunately led to a huge calculated loss in energy, as well as my GlowScript code possibly not being correct. So the formula is used, and so first we have the velocity from position and time. Then we have the translational kinetic energy, which is, of course, 1/2 mv squared. The total kinetic energy is K total equals K trans plus K rotational. And we did not calculate K rotational in this, but you could definitely find it from finding the total kinetic energy and then subtracting K trans from it. We have the conservation of momentum, and then we have the percent energy lost. So here's the first tracker video. So we can see here that the pool ball is moving in both directions, and we were able to calculate it. Now, we do have a sloped plane, but I accounted for it in the video as well as the yardstick. So here are the experimental graphs, so we can see how the exposition of mass A and mass B, which were the pool balls, were able to changed with time. So here's the GlowScript code. So first I gave them obviously the properties of the pool ball and used the same colors in the code that I did in the experiment. And we have the arrows for the velocity visualization. And we have the time step settings and energy tracking. And then we have the while loop that updates the position and the velocity as well. We also have an energy update. And we have an optional energy label that shows the total energy lost. Unfortunately, this lab didn't really work too well. So here's the experimental versus computational videos again. So here's the GlowScript code first, using my code. And we can see here it models the video pretty well. And here we have the actual tracker video again. As we can see, they look pretty similar. So I would say my code worked out pretty well. So what if the collision was maximally inelastic or just inelastic? So if it was maximally inelastic, I'd expect the two pool balls to stick together and move as one after impact, which would result in maximum possible energy lost. So if it were just inelastic, the balls wouldn't stick, but some kinetic energy would still be lost, converted into heat, sound, or deformation, and we'd see a noticeable drop in final kinetic energy. So in theory, two pool balls should be mostly elastic. There is some energy lost due to sound, and of course the friction of the pool table has a lot of energy lost. So what if V average? So if we used V average instead of imported data, total V average, of course, it would have been incorrect. It would have just modeled displacement rather than distance. So I did use V average, but it was more so like a time step in each sequential time step data. So what if I accounted for K rotational? I'd probably recover a lot of the energy that seemed lost, since some of it went into spinning the balls, which isn't really accounted for in the code. The final energy would be much closer to the initial, and my model would better reflect how real pool balls behave. And so error, the angle of filming, of course, was a source of possible error. Massive energy loss due to velocity estimates because it's fragile data. I didn't use jitter and rotational energy, and the energy didn't vanish. It was just the code that I could have messed up, and it just can't see where the actual energy went. And that is it. Thank you so much.